In this video, we're going to continue with the Softjaw Mill project. To get an idea where we left off, I like to run the existing toolpaths inside of Verify. I'll select the entire first operation toolpath group. You get checks next to everything. And then I'll open up Verify. Takes a moment for Verify to open up. Once it's opened up, make sure the stop condition collision is activated. I got a check next to it. And then run it. So what we've done so far is we faced 20 thousandths of material off the top of the part. We machined the outside profile with a dedicated roughing tool, and then we came in and we finished the outside profile to the finished dimensions with a dedicated finishing tool. What we'll need to do now is we'll need to spot drill, create pilot holes for the drill that's going to go all the way through the part. We'll need to drill through with a 17/32 diameter drill, or the drill that's specified on the drawing. We'll need to machine the counter bores. We'll use a chamfer mill to break any sharp edges that we might have created. And we're also going to engrave our initials on this top face right here. So from here, I've got a good idea where we need to go. I'm going to exit out of Verify. Looking at it from an isometric view, we'll go back to the project page and we'll follow the instructions given there. So step 5, we just completed step 5, or we've completed step 5. We're moving on to step 6. Use the drill tool path to create the 0.25 pilot holes in the part. So I'm going to scroll all the way down to the tool list. We've used tool 1, the face mill. We've used tool 2, the dedicated roughing tool, and tool 3, the dedicated finishing tool. Now on tool 4, this is our 1/2-inch diameter spot drill, 90-degree DPA. We're being instructed to use a C4 C3-0032 tool holder, and the tool projection, or the tool stick out, is 1.5 inches. So I have enough information to work with. I'll go back into Mastercam. Make sure the insertion arrow is at the very end of the toolpath group. Go to toolpaths. In the 2D section, select drill. Brings up the toolpath hole definition dialog box. I'm going to select the large circle that represents the counter bore on this top face here. Now be careful, don't lock on to the quadrant. If you position your cursor on the outer edge of the circle, you'll see the center point icon pop up next to your cursor. That's what you want. So once you see the center point icon pop up, left click, you'll see a point appear at the center of that selected circle, and then do the same thing with the right side hole. So once again, locking onto the center, left click. I've got 2 points. The red one indicates the first hole to be drilled. The line shows the order that the hole will be drilled in. And we only have 2 in this case, so it's pretty straightforward. First hole, second hole. I'll scroll to the bottom. I don't need to change anything here. So from here, I'll select the green check. Select tool. We need to add the 1/2-inch diameter spot drill to our tool list. I'll select the select library tool icon. My filter is active, so I'm only seeing the 3/4 inch diameter drill. Select the filter icon. But before you do that, make sure the filter is active. So make sure there's a check next to filter active. Select the filter icon. I'll deselect drill. I'll select spot drill. And to see all of the spot drills coming out of the library, I'll set the tool diameter to ignore. From here, I'll select OK. Out of this library, we have 6 spot drills to choose from. The 1/2-inch diameter spot drill is the one I'm interested in, so I'll double click on it. And it's added to my tool list as tool number 4. I'll need to make some changes to the default settings of this tool. To do that, I'll right click on the tool. And from the flyout menu, select Edit Tool. Things that I'll change on this page. It's showing the cutting length to be 2 inches in length. On a spot drill, usually the cutting edge doesn't go beyond where the full diameter begins. And it doesn't have the ability to remove or evacuate chips beyond this edge in most cases. So to create a more realistic representation of the tool, I'm going to set the cutting length to the drill tip length. So 0.5 times 0.5. The cutting length is 0.25 inches long. And then for the shoulder length, I'll just set this to 1. Mastercam will only let us hold on to the dark gray area of the tool. So if this value is too great, it'll only let us have a tool projection or a stick out length of 2.5 or greater. So I'm setting this tool length to 1. And that way we can set our tool projection to 1.5. From here, I'll select finish. I should not have selected finish, my bad. So we're gonna have to go back into that tool. So right click, edit tool. This page is complete. I still need to go to the next page. So I'll select next. To get Mastercam to calculate the feed rates correctly, set the number of flutes to 1. To calculate the RPM, I'll select the calendar. And then to turn the coolant on, I'll select show more options. I'll select coolant. And then under flood, turn it to on. From here, I'll select OK. And that'll be all the changes that I need to make to this tool. So just to recap what we did, number of flutes 1, calculated the RPM, and then I turned the flood coolant to on. From here, I'll select finish. Back to this page, we've already calculated our RPM. We'll need to update our feed rate. Now with drills, think of the FPT as feed per revolution, FPR. And to calculate our FPR, we're going to take 2%, or the FPR will be equal to 2% of the tool diameter. So we have the decimal equivalent of the tool right here. I'll type in 0.5, multiply by 0.02. That's 2%, hit enter. Mastercam is calculating the feed rate for this drill to be, or calculating it at 11.46 inches per minute. I'll also provide a comment. Now my value is carried over, but if your field is blank, what you'll need to do, copy the name, paste it in the comment field, and provide some type of useful information. I'm going to say drill all pilot holes, and do this in cap letters. So drill all pilot holes.
Oh, Professor?
Yes, sir.
Yeah, so during the midterm, are we gonna do we need to know the feed rate or FPT, or are we just gonna go with whatever the default is?
I will provide that information to you guys. So I'll say for all end mills, use a FPT, a cutting speed of 300. Use an FPT equal to 1% of the end mill. If it's an end mill, you're going to use 1%. And if it's a drill, you're going to use an FPT, but you need to think of it as FPR, an FPT equal to 2% of the tool diameters. Does that make sense?
Yeah, yeah.
And I'll provide that in the note. There'll be some descriptive instructions or thorough instructions on what you'll need to do. Basically, just follow this, instructions step by step. We do see that in our project page. We provide you with a tool list. We provide you with some instructions, but I'll even carry it a little bit further. I'll give you some more information with these instructions. So step 1 through step whatever, it'll be laid out very similar to what you see on the project page. And I'll try to, and I will definitely provide you with all the information that you need. All right.
Oh, yep. Thank you.
You're welcome. Good question. So from here, I've completed this page. Now, once again, make sure that these notes or these comments are all caps. From here, we're going to go to the tool holder. And we're going to use the tool holder that we're instructed to use, or the tool holder that's been identified on the project page. So go down to the tool list. And we're using a C4C3-0032. Tool projection is 1.5 inches. Now that's a Cat 40 inch tool holder. Instead of looking through this long list of tool holders, I'll go to Open Library. CT40-IN, Cat 40 inch, open it up. And it's a shorter list. These are all Cat 40 tool holders. I'm looking for the C4C3-0032. This is a ER32 type tool holder. It's a collated tool holder. Set the tool projection to 1.5 inches. And that'll complete all of the changes that we need to make on this page. From here, go to cut parameters. The cycle should be drill /counterbore. And if we have the dwell value set to 0, it's going to create a G81 drilling cycle inside of our NC file. And that's what I want. We're creating a pilot. There's no need for a dwell, so set this to 0. From here, jump down to linking parameters. We're going to use the same clearance that we used for the previous toolpath. So activate clearance, set it to absolute. We're using a clearance plane of 3.5 inches. That'll place the tool 2 inches above the top of the part, or at least 2 inches above the top of the part when it's rapiding from one location to the other. I'll check use clearance only at the start and the end of the operation. For the retract, I have it set to incremental. I'll set the retract value to 0.1. For the top of the stock, I'll set it to absolute. I remember our origin is at the bottom of the material. So this top of stock is going to be greater than the part thickness. So I'll select the top of stock icon. I'll let my cursor lock on to the top of the part. 1.48, absolute. And for the depth, I'll set it to absolute. I'm creating a counter or a pilot or a countersink. And we can control the diameter of the countersink by using the calculator that's provided. So in this case, I'll select the calculator. From the depth calculator dialog box, I'll select overwrite depth. And for the finish diameter, we're instructed to create a pilot 0.25 in diameter. So set the finish diameter value to 0.25 and hit enter. From here, select OK. And you can now see the value here, the top of stock is 1.48. The depth that we're drilling to, now remember, this is relative to the top of the part, or relative to the, I should say relative to the coordinate system. But the difference between these two will actually be the depth that we drill to into the material. Tip comp is turned off. Make sure tip comp is turned off. If you have it turned on with a spot drill or a center drill, you will not like the results. And from here, I'll select OK. I can see the tool path. The yellow lines represent rapid moves. And if I zoom in, you can see the blue lines. Those are feed moves. So the blue line represents the drill moving through the material at 11.46 inches per minute. I don't see any issues inside of or with the tool path, things I might be looking for. If this yellow line was moving through the material, I could then see that I would have a problem. So I don't see any issues with the tool path yet. We'll run it in backplot. And to do that, I'll select the tool path. I got a green check next to just that tool path. I'll select the backplot icon. And slow it down a little bit with just 2 holes. I want to go kind of quick. So slow it down, select play. A little too slow, so I'll speed it up. Not seeing any issues with backplot. So from here, I'll exit out of backplot. I'll toggle off the display of that drilling operation. So toggle display. I'll look at it from an isometric view. I'll fit my screen and I'll unzoom a little bit. So unzoom 80%. And before I go to verify, I like to save my work. So file save. To run the entire toolpath group inside of verify, I'll select the entire first, I'll select the first operation toolpath group. You see green checks appear next to everything. And then I'll select verify. Double check, make sure stop condition collision is turned on, and then run verify. I'm inspecting the machine model and you can see the pilots, the 1/4 inch pilot holes drilled at the top of the part or on the top surface of the part. And these are designed, or their intention is to guide the drill that's going to go all the way through the part. So everything looks good here. From here, I'll exit out of verify. I need to create a stock model that reflects everything or that reflects all of the tool paths that we've created up to this point. Make sure that the insertion arrow is at the very end of your toolpath group. Go to the toolpath tab. In the stock section, select stock model. In the name field, let's call this drill pilot holes. Stock plane, I have it unchecked. It's at the top. Initial stock plane. Let's use the stock model from the previous operation. So select stock model, expand the stock model menu, and I'm going to use the finish pass outside contour. Now yours might be named slightly different. This is a stock model that I created from the last toolpath that we created, or the previous toolpath that we created. So I'll select that stock model, and then I'll go to source operations. And for the source operation, let's select the drilling operation that we just created. I'll select OK. You'll see the stock model appear. And I like to inspect it and make sure that it's correct. So you can see that the majority of the material is still inside of the holes, but you can also see the pilot at the top center of the hole. So that's what I wanted to see. Everything looks good. From here, I'll toggle off the visibility of the stock model. Once again, I'll look at it from an isometric view and I'll save my work. So now that we've created the pilots for the drilling operation, I'll go back to the project page and moving on to, let's see here. Oh, something's happening here. So creating, okay, got it. So we have moved on to step 7. We've created the pilot holes. We're now going to drill through. So use the drill toolpath to create the 17 32nd diameter holes in the part. And if I look at the blueprint, just to check, the 17 32nd diameter hole goes all the way through. So we'll have to do that. We'll have to make sure that we do that inside of the program. If I go down to the tool list, tool number 5, this will be our 17 32nd diameter drill. It's got 118-degree drill point angle, DPA. And we're instructed to use a C4C3-0032 tool holder. Tool projection will be 2 inches. Okay, so let's go back into Mastercam. Now, something that we can do, it might save us a little bit of time. It might cause more problems. We could actually copy this tool path. I don't know if I've shown you guys how to do that yet, but If you've got drilling operations, sometimes there'll be a sequence of drilling operations. It could be a pilot, a drilled hole, a countersink, a tap. So there could be a series of drilling operations that are considered similar or like drilling operations. And in situations like that, it'll save you a lot of time where you copy existing tool paths, make a few changes to that copied tool path, and it works for the next tool. So let's try doing that. We'll have to be very careful on how we go about doing it. First off, if you have everything selected, select just the item that you want to copy. So I'm going to copy the drilling operation that we just created. So in my case, it's the 8 or operation 8. There's a green check next to just number 8 or the drilling operation. With just that item selected, right click on it. From the flyout menu, select copy. Make sure the insertion arrow is at the very end. And next to the insertion arrow, right click, paste. We now have 2 tool paths, pretty much doing the exact same thing with the exact same tool. We're going to go into the new tool path and make changes so that it works for the 1732nd diameter drill. Was everyone successful with copying and pasting the drilling operation?
It's not letting me paste it for some reason.
It's not letting, okay, let me take a look at your screen. So I'll stop sharing my screen. Let's see what you have going on.
Sorry, I'm still running it on my laptop.
Okay, I can't help you there.
You try Control V. It worked for
You
me.
could probably do that.
Yeah,
Okay, so was anyone else not able to right click and paste it? That might be a version, that might be a new situation with the home learning edition. So the other option, like we just heard, if I cut that out, if I select it, Control C, I think I just copied the text. So with just that one selected, Control C, and select next to the insertion arrow, Control V, didn't work. Okay, that time it worked. So I now have the new toolpath. So Ben, were you able to get that to work?
yeah, the Control V worked.
All right, perfect. So once you have that new toolpath pasted in your toolpath manager, expand it. And can you guys see my screen?
Yeah.
Okay, perfect. So once you have that toolpath pasted into your toolpath manager, select parameters and then go to tool. This particular toolpath is currently referencing the 1/2 inch diameter spot drill. We're going to add the 1732nd diameter drill to our tool list. Select the select library tool. Now my filter is still active, so I'll go to filter. I'll deselect spot drills. I'll select the icon right above spot drills, drill. And for the tool diameter, it's currently set to ignore, set it to equal. And then in the value field, type in 17 divided by 32 or the decimal equivalent of 1732. So 17 divided by 32, hit enter. 0.53125 is the decimal equivalent. I don't expect you to remember that. So from here, I'll select OK. I've got one tool that fits that description. Double click on it. And it's added to my tool list as tool number 5. I'll need to edit the default settings for this tool. Right click on the tool, select edit tool. Right away. If I remember correctly, we were told to use a tool projection of 2 inches. So I'll need to make some changes to the cut length and to the shoulder length. Go back to the project page, saying tool projection is 2 inches. To make that work, let's set the cutting length to 1.75 and then set the shoulder length to 2. And that'll allow us to have a tool projection or set the tool projection to 2 inches. Once you make those changes, select next. On this page, we'll start with changing the number of flutes. To get Mastercam to calculate the feed rates correctly, set the number of flutes to 1. And we do that for drills. To calculate the RPM, select the calculator. To turn on the coolant, select show more options, select coolant, and then set the flood coolant to on. From here, I'll select OK. And that should complete all of the changes that we need to make to this page.
Oh, Professor, can you go back to the tool edit again?
Yeah, sure. Tool edit, back to the geometry page.
Yeah, that one. No, this is good. I just wanted to.
Yeah, so the cutting length 175 or 1.75, and then the shoulder length 2.
Then you had 1 flute. Right?
Yeah, that's on the next page. Set the number of flutes to 1. Select the calculator and turn the flood coolant on.
Cool. Thanks.
All good?
Yeah. Thanks.
Hey, you're welcome. So from here, let's select finish. And you can see the RPM has been calculated, and this is a rounding issue. So we use a 150, but what you're seeing here is a reduced value, or it's because we want a whole number here. So that's what's actually being used. It's still 150. Just look at it that way. It's so close. We'll just call that 150. For the feed rate, we're going to calculate that by setting the FPR equal to 2% of the tool diameter. So the decimal equivalent of the tool diameter is up here. And in the FPT field, think of it as FPR, 0.53125 times 0.02, 2%. And I don't think I did that correctly. So 0.53125 times 0.02. It's calculated my feed rate at 11.45375. Now, what's going to happen is when we create our NC file, Mastercam is going to round this to 2 decimal places. So that'll become 11.46.
My SFM is higher for some reason. It's 159.
159.
Yeah, mine was 2.
So when did you guys see what I did for, who was that? I just altered somebody's. Was that Tan? Was that you?
Yeah, mine is
So-
like 300.
Yeah, so I'm going to select OK. I'm going to have to do the same, select OK. Go to tool settings. So you exited the tool path. Go to tool settings. Where it says material, go to edit. I believe yours is set to 60% right here. So percentage of base, what is your saying right now?
Mine's at 50.
It's at 50?
Yeah.
Okay. And what was the other one at? Okay. So now go back to the parameters. In this field, make sure you type in 0.53125 times 0.02. So 0.53125 times 0.02. And mine's at 11.46. Did that resolve the problem?
It's calculating the feed rate as 12.17.
What's your FPT?
0.0106.
0.0106. What's your spindle speed?
That's set to 1146.
1146. And your SFM, what's your SFM?
159.
159. Okay, so this is what we're gonna do. Go back to right click on the tool, select edit tool. Go to the next page. Are you on the same page as me?
Yes.
Select the calculator.
It has
And
the
what's your RPM now? What's that?
SFM is 149.
0.91819. That's correct. So, and your RPM, your spindle speed should be 1078. Is that what you're getting?
Yes.
Perfect. Okay, select OK. Oh, I'm sorry, select finish, my bad. And now in these fields, you should see the updated SFM and the updated RPM or spindle speed. Now go over to the FPT. Now you'll notice when you go back in and edit the tool definition, it changes the feed rate back to whatever it was previously. So in the FPT field, take the tool diameter 0.53125 times 0.02, enter. And you should get 11.45 and some change for your new feed rate.
Yeah, that fixed it.
Perfect. Cool. So from here, let's make sure we have a comment in the field. This comment is from the previous toolpath. Remember, we copied this toolpath, so clear that out. I'm going to borrow the tool name. I'll paste it down in the comment field. And let's do this. Say drill all holes through. And that'll complete all the changes that we need to make to this page. We're going to use the same tool holder that we used for the previous tool. So go to holder. We're going to look in the Cat 40-inch tool holder library. So go to open library. CT40-IN. Open that up. And we're going to use a C4C3-0032. Select it and set the tool projection to 2 inches. And that's what we're instructed to do on the project page. So the tool projection, you need to be aware of what your tool is, what you need the tool to do. So if I was drilling a hole that's 3 inches deep, would this situation or would this setup work for me?
No.
No, it would work until we got to about 1.999 inches into the part. Does that make sense? And then that next peck would be pretty bad. So you want to make sure that the tool projection is greater than the depth that you're drilling to. So just something to be aware of. And the tool projection will also be, with other tools, it just needs to be long enough so that when you're cutting the part, the collet nut or the tool holder doesn't run into the material. So that's what we're controlling here. So when we set these values will turn up later in the setup sheet. And that's how deep, or that's how far the setup guy knows to extract the tools from the tool holder. That make sense? All right, so from here, let's jump down to cut parameters.
Oh, Professor, for some reason it won't let me enter 2. It says assembly name 2.5 to 3.
So remember when I set the cut length, the 1.75 and the shoulder length to 2? Did you do that?
Let's see here. Edit
I thought I stepped you through that because you asked me to open up the page and you were
Yeah,
looking right.
I did. The
Yeah,
overall,
so it's so go back to tool, edit tool. Oh, mine's taking a while. Now here, you got this page open?
okay. I didn't have it set to 2. I had it.
Yeah, so
Yeah.
it only lets us hold on to the dark gray. Now, this isn't a very realistic scenario. with drills, you could probably choke up on them even onto the cutting flute, which I don't recommend, but it's possible. So Mastercam only lets us hold on to the dark gray area of the tool. So that's why we have to change the cutting length and the shoulder length. So cutting length, I had to shorten it, the shoulder length, I had to shorten it. And in this case, the shoulder length is becoming our tool projection. So from here, I'll select finish. Now, the drawback of going back into the tool or editing the tool is it changes my feed rate back to whatever the first value was. So I have to go to FPT 0.53125 times 0.02. I have to recalculate my feed rate. I'll jump down to cut parameters. Now, when we changed over to a regular style drill, not a spot drill, Mastercam changed over to a peck drill cycle. And then the peck increment is equal to the drill tip length. From here, go to linking parameters. Remember, this is a copied toolpath, so most of this information is already filled out. Everything will work except the depth. The depth was calculated by Mastercam to create that pilot. I need this hole to go all the way to the part. So I'll select the depth icon. I'll select the bottom of the part. And you can see that it's now drilling to 0.23 relative to the origin. Now, this value is telling it how far to send the tip of the tool into the part. I need a full diameter going all the way through the part. So I'm going to activate tip comp. So select tip comp, select the checkbox, set the breakthrough amount to 0.025. And you can see, this graphic here explains what's going on. This is the bottom of our part, and you can see it's going to go an additional amount based off of this breakthrough amount. And then the tip length that Mastercam is calculating. This tip length is based off of the 118-degree DPA, and that matches our tool. So from here, I'll select OK. Now, because it's a copied toolpath, we'll need to regenerate it. So I'll select regenerate dirty operations. And now with just that new toolpath selected, I'll run it in backplot. I can see that the tool is going all the way to the part, and to double check that, if I look at it from a front view, I'm hitting the S key to signal step through. Now, here's our final depth that we're drilling to. And I can see the full diameter is going all the way to the part, and that's what I want to see. So that looks good. From here, I'll exit backplot. I'll look at it from an isometric view. I'll save my work. And we're going to run the entire toolpath group inside of Verify. So I'll select the first operation toolpath group. I get green checks next to everything. I'll select Verify. Make sure stop condition collision is turned on. And run Verify. Now to inspect the machined model or machined part, I want to see how deep the drill has gone into the part. And I want to change over to a translucent stock. And you can do that inside of Verify. So Home tab, in the visibility section, you'll see a checkbox or a check next to stock. If you left click on it once, it changes over to a square inside of that box. And our machined model is now transparent. And I'm zooming in, and you can see this circle here, this bottom edge of the hole. You can see the profile of the drill goes all the way through, or the full diameter of the drill goes all the way through. And that's what I wanted to check for. So once you verify that the machined model is correct, if I select stock, again, it changes over to a wireframe view. There's the box is empty. If I select it again, the check reappears and we are now looking at a shaded view. So everything looks good. From here, I'll close out the verified. I'm looking at it from an isometric view. And the next thing I'll do is I'll create the stock model that reflects everything that we've done up to this point. The insertion arrow is at the very end of the toolpath group. From the toolpaths tab, in the stock section, I'll select stock model. For the name, let's call it drilled holes. For the initial stock shape, once again, we're using a stock model. Let's use a stock model from the previous operation. So drill pilot holes in my case. And then for the source operation, let's select the drilling operation that we just created. And then I'll select OK. Mastercam processes the stock model. You can now see we've got the drilled holes going through the part. The next thing we'll need to do is machine out the material to create the counterbores. Once you verify that the stock model is correct, toggle out the visibility of it. Looking at it from an isometric view, and I'll save my work. So now that we've drilled the 17/32 diameter holes through the part, I'll go back to the project page. And we're looking at the next step here. Let's see, we are instructed to step 8. Use the helix bore toolpath to create the 0.813 counter bores in the part. Okay. And we'll also check out the tool list. Let's see what tool they need us to use. So we just brought in tool 5, the 17/32 diameter drill. Tool 6, it's going to be a 3/8 inch flat end mill, 3 flute. And we're going to use a C4E4-0375 tool holder, and we'll have a tool projection of 1 inch. So this is a solid type tool holder. There will be a set screw that lands on the flat of the shank of the tool. So let's do this. We'll go back into Mastercam. The insertion arrow, very end of your toolpath group. From the toolpaths tab, in the 2D section, I'm not seeing the helix bore toolpath. So I'll need to expand the gallery. And in the hole making section, you'll find helix bore. So toolpaths, 2D, expand the gallery. In the hole making section, helix bore. Brings up the toolpath hole definition dialog box. Once again, we need to select the 2 holes that we're drilling or creating the holes in. Select the 2 circles that represent the top of the 2 circles that represent the diameter of the counter bore, the ones that are on the top of the part. So I'll select here, and I'll select here. 0.813 in both cases. I'll select the green check. Brings up the helix bore dialog box. Start by going to the tool. We're going to add that 3/8 diameter flat end mill to our tool list. So I'll select library tool. Now it's already here, but you guys probably don't see that. So make sure the filter is active. So I have a check next to filter. Go to the filter icon. Let's assume that I have all tool types selected. So I'll start by selecting none. I'll select end mill flat. Set the tool diameter to equal, and then set the value to 3/8, 3 divided by 8, or you could type in the decimal equivalent, 0.375. Either way, either one will work. From here, select OK. I've got one tool that fits that description. I'll double click on that tool. It's added to my tool list as tool number 6. We'll need to make some changes to the default settings for this tool. So right click, edit tool. We'll need to make sure that the cutting length is greater than the depth that we're machining to. If I go back to the blueprint, it's called out in 2 places. So this call out here, this is the one that is driving our program. This is a reference dimension. So anytime you see a reference, there's a good chance, more than likely, that there's going to be another version of this dimension telling us, how deep we're going to drill to, or how deep we're going to cut this pocket to, or this counterbore to. And this is the driving dimension. So the counterbore is 0.6 deep. We need to make sure that we have at least 0.6 of cutting length. In this field, you can see the cutting length is 0.75, so we should be good. From here, go to next. The number of flutes, set this to 3. To calculate the RPM, select the calculator. To turn on the coolant, select show more options, select the coolant icon, and then set the flood coolant to on. I'll select OK. For the finish XY step percentage, set this to 2%. And that'll complete all of the changes that we need to make on this page. So number of flutes is 3. I calculated the RPM, I turned the coolant on, and then I set my finish XY step percentage to 2. From here, I'll select finish. Back to this page, the RPM has already been calculated. For the feed rate, this is an end mill. We're going to set our FPT equal to 1% of the tool diameter. The decimal equivalent is here, 0.375. So 0.375 times 0.01, hit enter. My feed rate has been calculated at 34.38. Let's set our plunge rate to half the calculated feed rate. So what I'll do in this case, I'll type in 34.38, divide that by 2. I've got rapid retract selected and we'll provide a comment. So I'll borrow the tool name. I'll paste it in the comment field in all caps. Let's say machine counterbores. That completes everything I need to change on this page. Go to the tool holder. From the tool list, we are instructed to use a C4 E4-0375 tool projection 1 inch. So C4 E4. This will be a Cat 40 tool holder. So go to Open Library, Cat 40 inch, C4 E4, right here. So C4 E4-0375. The last 4 digits represent the diameter of the bore in the tool. So this is a 0.375 diameter bore. For the tool projection, set this to 1. And that will complete all of the changes that we need to make on this page. From here, go to cut parameters. For the compensation type in our program, we use where. Compensation direction, left should be left. Diameter for simulation, we'll just leave this blank for now. Start angle, I'm going to accept the defaults. on the most of these. For the stock lead on wall, set this to 0. Stock lead on floor, set this to 0. For the rough finish, I'm going to accept the rough pitch, the default for the rough pitch at 0.08. You can see the helix here, and then the pitch or the distance from one spiral to the next as it's descending is going to be 0.08. We're just gonna do it in one rough pass. Feed rate at final depth. So we can actually control it. We can reduce it so it gives us a nicer finish. I'm gonna bump this up a little bit. I'm gonna keep this at 75%. It's still a reduced feed rate, but it's quicker than what the default value was. For the finish method, so I'm activating finish. Set the finish method to circle. Finish step over, that's that 2% of the tool diameter that we were talking about. The feed rate, it's bumping it up to 125%. Let's just set this to 100 or 100, I should say. Spindle speed, we'll keep that at 100%. And I think that will take care of everything. Go to linking parameters. Oh, we have to set all these values. This is a brand new toolpath in this session of Mastercam. So set the clearance to 3.5 absolute. I'll use clearance only at the start and the end of the operation. I'm turning retract off. I'll keep my feed plane at 0.1 incremental. Top of the stock, I'll set it to absolute. I'll select the top of stock icon. And I'm going to pick something that represents the top of the part, which is the top of the counter bore. So I'm going to select the top of the circle here. For the depth, I'll set it to absolute. I'll select the depth icon. And this time I'm going to lock on to something that represents the bottom of the counter bore. And I'm getting 0.88 absolute. The difference between these two values should be 0.6. And that should cover everything. We'll run it in backplot and see if we need to make any changes. So from here, I'll select OK. I don't know if that's going to work. We'll see. So from here, I'm looking at the toolpath. I don't see any rapid moves moving to the part. With just that helix bore toolpath selected, I'll run it in backplot. Select play. So it does a helical motion all the way to the bottom of the pocket. And then when it gets to the bottom of the pocket, it does one final pass where it removes that extra, whatever 2% of our tool diameter was. So I'm liking what I see. Don't know if I like how it arcs in and arcs away. We'll see how that
path is helicing back out. It's not just pulling it back out.
I can barely hear you. And can you repeat that, please?
My toolpath, it's doing the helic motion in and out, not just in.
Okay, so look at my screen here. Let me show you what I believe is causing it. If you go to, let's see here, go to rough finish. So under finish, your finish method, do you have it set to helix upwardly or do you have it set to circle?
That's what it was. Thank you.
Okay, perfect. Yeah, so this is what's controlling that. You can do a finish pass where you get to the bottom, then you come right back up doing a helix, or you can, it'll back out and then do another helical entry or a downward helix. What I prefer is when it gets to the depth of the counter bore, it just does one finish pass at the final depth. So from here, I'll select OK. It looked good in backplot, so I'll toggle off the toolpath. I'll toggle off the visibility of the toolpath. I'll save my work. Looking at it from an isometric view, might zoom in. And I might zoom out a little bit. So from here, make sure you save your work. I recommend saving your work prior to going into verify. I'll select the entire first operation toolpath group. Let's run it and verify. So select the verify icon. Stop condition collision is turned on. And then I'll select play. I'm tumbling my view. And if I zoom in, I'm inspecting the drilled and counterbore holes. And you can see that the machined model pretty much matches up with the wireframe representation of the drilled and counterbore holes. Now, if you zoom in too close, you can see some imperfections or some jaggedness, but for the most part, it lines up. So I like what I see. From here, I'll exit verify. And I'll look at it from an isometric view and I'll save my work again. We'll need to create the stock model that reflects all of the machining that we've done up to this point. I've got the insertion arrow at the very end of the toolpath group. Go to the toolpaths tab. In the stock section, select stock model. And for the name, we'll call this machine counterbores. Stock planes at the top, initial stock shape. Once again, we're using a stock model, using a stock model from the previous operation. And then for the source operation, select the toolpath or the helix bore that we just created. Select OK. Mastercam processes the stock model. And once again, you want to inspect the stock model very much like you do inside of verify. Just make sure everything is correct. And once you verify that it's correct, toggle off the visibility of the stock model. And I'll save my work again. So now that we've created the counterbores in the part, we're going to move on to breaking the sharp edges around the part. Let's check the project page to make sure I'm doing things in the correct order. So let's see here. So step 8, use the helix bore toolpath to create the counterbore holes. We did that. Step 9, use the contour toolpath to create the engraved initials on the part. Okay, so I'll go down to the tool list. And the next tool, tool 7, is going to be the 1/32 ball mill. And the tool holder will be actually a 2-flute ball mill. Tool holder will be a C4C4-0016, and the tool projection will be 1/2 inch. To engrave the initials, I'll go back to the level manager. I'll make my name level visible. You can now see the geometry that represents my initials on the top of the part. So back to the toolpath manager. I'll go to toolpaths. We're going to use a contour toolpath to do the engraving. Go to 2D contour. That brings up the wireframe chaining dialog box. Now, if it brought up the solid chaining box, solids or solid chaining and wireframe chaining. This is the mode that you want to be in, wireframe. C plane is selected. Change this to 3D. So mode, wireframe, change it to a 3D. And then for the selection method, I'm going to use window. I'll look at it from a top view. So in my graphics area, I right click on the screen. I'll select top. And I'm going to create a window around the geometry that represents my initials. So drag a window over the initials, left click. The prompt changes. It's now saying sketch approximate start point. I'm going to let my cursor lock on to the bottom left corner or bottom left point of my first initial. And then everything becomes selected. I'll demonstrate that again. So for me, just deselect everything. Using the window method, I'll create the window around my initials. So it's prompting me, it says select contour chain one, sketch a window to select any. So left click, drag the window, left click to select it. Now it doesn't look like anything has happened, but the prompt has changed. I'm now going to let I'm now going to let my cursor lock onto the bottom endpoint of my first initial, left click. From here, I'll select OK. And that brings up the parameters for the contour toolpath. Let's start by bringing in the tool. I'll go to select library tool. We're going to bring in a 1/32 ball end mill. So I'll go to filter. I'll start by deselecting all tool types. I'll select none. Then I'll select end mill to sphere. For the tool diameter, we're looking for a very small tool. So what I'll do is I'll set this to less than, and then I'll type in 0.125. So it's going to show me all tool diameters or all ball mills that are less than 0.125 in diameter. I'll select OK. I have two tools, or I'm sorry, I have three tools to select from. I'm looking for the 1/32 ball end mill. I'll double click on it. It's added to my tool list as tool number 7. We'll need to make some changes to the default settings of the tool. So right click on the tool, select edit tool. Now, the first thing I want to change is the overall length. This is a somewhat unrealistic representation of this tool. So set the overall length to 1. That'll be all the changes that we make to this page. Select next. Set the number of flutes to 2. To calculate the RPM, select the calculator. It's maxing out at 10,000 RPM. To turn on the coolant, I'll select show more options. I'll select coolant. And then I'll set the flood coolant to on. From here, I'll select OK. That'll be all the changes that we need to make to this page. So just to recap what I did, number of flutes, set that to 2. I calculated the feed rate, the RPM, I'm sorry, calculated the RPM, and it maxed out at 10,000 RPM. Then I turned the coolant on. From here, I'll select finish. The RPM has already been calculated. You can see it here. For the FPT, set this to 1% of the tool diameter. Here is the decimal equivalent of the tool diameter. So in this field, I'll type in 0.03125, multiply it by 0.01. I hit enter. My feed rate is being calculated at 6.25 inches per minute. This is my full feed rate. I would like to set my plunge feed rate or plunge rate to half the calculated feed rate. So in the plunge rate field, I'll type in 6.25, divide that by 2. I've got rapid retract selected. And then in the comment field, I'll paste the tool name. And some type of useful information, all caps, engrave, initials. That'll complete all of the changes that I need to make on this page. From here, I'll go to holder. Now, once again, this is a Cat 40-inch tool, so I'll open up the Cat 40-inch tool holder library. So CT 40-inch. If I go back to the project page, we are looking for a C4C4-0016. So C4C4-0016. And then we're instructed to use a tool projection of 0.5 inches. That'll complete all the changes that I need to do on this page. From here, go to cut parameters. When we engrave with a contour toolpath, we need to turn the compensation type to off. Contour type should still be 2D. And then I'm accepting the default values for everything else. I've got 0 for stock to leave on walls and 0 for stock to leave on floors. I've got depth cuts turned off, no check here. Lead in, lead out. Let's turn it off. So uncheck it. Breakthrough. Uncheck, breakthrough, turn it off. Multi-passes, not using multi-passes. So once again, if you have it activated, uncheck it. From here, go to linking parameters. Now, because we've used other contour toolpaths in this session of Mastercam, a lot of these values are carrying over. So the clearance at 3.5 is good. Feed plane 0.1 incremental is good. Top of stock. I want to select the top of the part. This top of stock is the top of the material. So I've got it set to absolute. I'll select the top of stock. I want to lock onto something and let my cursor lock onto something that represents the top of the part. For the depth, once again, set it to absolute. I'll select the depth icon. And in this case, I'm going to lock on to the top of the part. It puts that value in this field. And then I'll click next to the value and type in -0.005 and then hit enter. So the difference between these two is 5 thousandths. This is the top of the part. We're going to a depth of, no, this is relative to the origin. So the difference between these two is the actual depth that we're machining into the part, 0.005. From here, I'll select OK. I don't like how it's retracting all the way back up to 3.5 inches. So to avoid that, what I would do is I'd go back into the parameters. Under linking parameters, let's activate retract. And in this case, we could set it to, let's leave it at 0.25 incremental. It'll be 150 thousandths above the feed plane. I do have use clearly at the start and the end of the operation selected, so I'll select OK. I'll regenerate the dirty operation. And that looks to be a little bit more efficient. We're not wasting time going all the way back up to 3.5 inches. It appears to be good. So with just that toolpath selected, I'll run it in backplot. Now it's difficult to see because the tool is almost as wide, or the line that represents the rapid and feed move, or in this case, rapid move, is almost as wide as the tool's diameter. So from here, I don't see any issues. I'll exit backplot. I'll toggle off the visibility of that toolpath. I'll look at it from an isometric view. Hit my screen and then I'll unzoom by 80%. Before I run it and verify, I want to save my work. So file, save. I'll select the entire first operation toolpath group. Just select the first operation toolpath group. Everything below it becomes selected. And then I'll run it and verify. Inside of verify, make sure stop condition collision is turned on, and then run it. Once it's done running and verify, I'm zooming into my initials and I'm inspecting the machined model. And what you should see is you should see the engraving with the wireframe geometry centered on it. So we're telling the toolpath, we're telling the Mastercam to take the center line of the tool and follow the driving geometry. And that's what I'm getting here. So this looks good. From here, I'll exit verify. I'll look at it from an isometric view. I'll save my work. The next thing we'll need to do is create the stock model. Go to tool paths. In the stock section, select stock model. For the name, let's call this engraved initials. For the initial stock shape, I'm going to use the stock model from the previous operation. And then for the source operations, or for the source operation, select the contour toolpath that we just created. This is the contour toolpath that we're using for the engraving. Select OK. It's not easy to see the engraving on the stock model. So what I'll do is I'll go to the level manager and I'll make the solid model level and the name level invisible. And now it's easier for me to see the engraved initials. Once you verify that it's correct, you can make the solid model level visible. I'm going to look at it from an isometric view. Back inside the toolpath manager, I'll toggle off the visibility of the stock model, and then I'll save my work again.